All Academy. Always with you.
Hello my dear students, welcome to this online video lecture on basic thermodynamics. So in a previous session we have discussed the various important concepts of thermodynamics from the first module, that is thermodynamic properties, thermodynamic equilibrium, thermodynamic cycle, then what is reversible and irreversible process, then what is quasi-static process. So all those things we have discussed and hope that you are clear with the topics which are discussed in the previous session. So today in this session we are going to discuss about the zeroth law and the application of zeroth law. Then again we'll discuss the methods, that is the temperature measuring concepts. Then we'll see the methods adopted to measure the temperature. Then the types of thermometers, which are the types of thermometers used for temperature measurements. So without wasting much time, let us begin with today's session.
So let us begin today's session with a thermodynamic equilibrium. So what is this thermodynamic equilibrium? A system is said to be in a thermodynamic equilibrium if it satisfies the condition for thermal equilibrium, mechanical equilibrium, chemical equilibrium and electrical equilibrium. That is, if I want to say any system as a thermodynamic equilibrium, then that particular system or a body must satisfy these four equilibriums. So then I can say that the system is said to be in a thermodynamic equilibrium. So which are those main equilibriums? That is thermal equilibrium, mechanical equilibrium, chemical equilibrium and electrical equilibrium. If these all conditions are satisfied, then I can say that for any system is to be in a thermodynamic equilibrium. So during this thermodynamic system, there will be no changes occurs in a system. That is very important. If I say that that the particular system is thermodynamic equilibrium, then there will be no changes occurring in that particular system. Or else I can say that, so there will be no process taking place in a system. So let us study these thermodynamic equilibriums, definition of these mechanical equilibrium, chemical, electrical and thermal equilibrium. So what is this mechanical equilibrium? A system is said to be in a mechanical equilibrium if there is no unbalanced force within the system or at its boundaries. Means if I want to say the system is in a mechanical equilibrium, then there must be no unbalanced force within the system. Then I can say that the system is in a mechanical equilibrium. Now if I want to say that any system to be in a chemical equilibrium, then there must be no chemical reaction or a process within the system or at its boundaries. It means that, so if I want to say any system is in a chemical equilibrium, so within that system or from system to surrounding, there must be no chemical reactions taking place in that system. Now if I want to say thermal equilibrium, a system is said to be in a thermal equilibrium when there is no temperature gradient, means there is no temperature difference between the system or surrounding or within the system. Then I can say that the system is in a thermal equilibrium. And the last one is a electrical equilibrium. A system is said to be in a electrical equilibrium when there is no electrical potential gradient within the system or between the system and its surrounding. If I want to say any system is in an electrical equilibrium, there must be no electrical potential gradient. Then I can say that the system is in a electrical equilibrium. So what is this mechanical equilibrium? There must be no unbalanced force. Chemical equilibrium, there must be no chemical reaction or a process. Thermal equilibrium, there is no temperature gradient. And electrical equilibrium, there must be no electrical potential gradient. So let us know what is this dithermal wall and adiabatic wall. An envelope or a boundary or a surface that enclosing the system, means the outer layer of a system which may behave as a conductor or insulator. In some condition it may behave as a conductor, and in some condition this boundary may behave as a insulator. So when I can say that this surface or a boundary is dithermal, or when I will say this boundary is a adiabatic. So let us discuss about that one. If the contacting wall or outer surface of a body or a system is a conductor, which allows the heat energy to pass through the boundary or the wall. Then I can say that such a walls are called as, or such a boundaries are called as dithermal wall. As you are seeing in this figure, the boundary is allowing the heat energy to enter into the system. At the same time, it is allowing to cross from the system to surrounding. Means any boundary which conducts the energy or which allows the heat energy to pass through from system to surrounding or from surrounding to system, then such a boundaries are called dithermal wall. Now what is this adiabatic wall? So the adiabatic wall is nothing but it is a contacting wall, or it is a boundary, or it is a outer surface of a body which acts as an insulator, that is which does not allows the heat to flow across the boundary. Means it does not allow the heat to cross the system to surrounding or from surrounding to system. Then such a boundaries or a outer surface, I can say that it is a adiabatic wall. Now let us discuss the zeroth law of thermodynamics, and this is a basic law of thermodynamics which we study even in class 12 and even in first year of engineering. So this is a basic law, and this is the first law what we'll study in this thermodynamics. So this zeroth law of thermodynamics deals with an equilibrium condition of a body. So when two systems have a thermal equilibrium with a third system, they in turn have a thermal equilibrium with each other. This is a simple definition of a zeroth law. So let us once again discuss. When two systems have thermal equilibrium within a third system, they in turn have a thermal equilibrium with each other. So this is a simple definition of a zeroth law. So let us know in detail about this zeroth law with some simple example. So let us consider the three bodies A, B and C. If body A and B are in a thermal equilibrium with each other, as you are observing in this figure, if body A and B are in a thermal equilibrium with each other, and body C and B are thermal equilibrium with each other separately, then the body A and C must be in thermal equilibrium with each other. So this concept is known as zeroth law of thermodynamics. So once again I will just repeat it. If A and B are in a thermal equilibrium, similarly body B and C are in a thermal equilibrium with separately, then I can say that body A and C must be in a thermal equilibrium, or they will be in a thermal equilibrium with each other. So best example, so but this whatever example I'm taking, this is not related to thermodynamics. Just to understand this zeroth law, I'm taking this example. So the example, the Facebook friends, what you are observing in Facebook, when you are friend with some person and he might be not in your friend list, but it will give some mutual friends. So that is zeroth law. In the simple words, I can say the whatever mutual friends you are observing, so that is a third person in equilibriums. So based on that, A and B, you are friend and you are a friend with some other person, and it is showing some mutual friends. So that is the zeroth law of thermodynamics. So A and B are in thermal equilibrium, B and C are in thermal equilibrium, then A and C will be in a thermal equilibrium. This is a zeroth law concept. This zeroth law of thermodynamics is used in the concept of temperature measurement. So this is a basis for a temperature measurement. This zeroth law is a basis. Now what is this temperature? Before going into the actual temperature measurement concept, so let us know what is this temperature. So temperature is defined as a thermal state which depends upon the internal or molecular energy. That is very important. So what is this temperature? Temperature is a thermal state which depends upon the internal and the molecular energy of a body. So I can say that this temperature is a measure of average heat or thermal energy of particles in a substance or a body. So as it depends on directly on internal and molecular energy, I can say that it is a average heat or thermal energy of particles. And one more thing, this temperature does not depends on any size or type of an object, as it is only depends on the internal energy. So this does not depends on the size or a type of an object. Now in other words, I can say that the temperature is a measure of degree of hotness or coldness of a body. I can say that it is a measure of hotness or coldness of a body. And the whatever instruments, the instrument used to measure these temperatures, we call it as thermometer. So generally for measuring the normal temperatures, we use thermometers. And for measuring high and sensitive temperatures, we use instruments called pyrometers. So the normal, to measure some normal and some up to some limited temperatures, we use thermometer, whereas to measure some sensitive and high temperatures, we use pyrometers. Now, these temperature measuring instruments are classified into based on the method how they calculate or how they will show the temperature. So based on the method of measuring, so these temperatures are classified into two types. One is non-electric method and another one is a electric method. So these are the two methods that are adopted or that are utilized in the measurement, temperature measurement concept. So in the non-electric methods, we by using change in the volume of liquid, then by change in the pressure of a gas, and by change in the vapor pressure with respect to temperature change, then we use such methods. As in this one, so we use the properties of some substances. Based on that, we measure the temperature. So here there is no any electrical concepts are used. So we call it them as a non-electric methods. Whereas in electric methods, we use some simple concepts of an electric like thermocouples, resistance of a material, then energy received by radiation, then color of a filament. These are the two methods. One is non-electric method and electric method. So here there is no electric concepts are used, and in electric method measurements, some electric basic concepts are used to measure the temperature. Based on these two methods, the thermometers are classified into 6 types. So one is expansion thermometer. Again in expansion thermometer, we are having liquid in glass thermometer and bimetallic thermometer. And the next one is a pressure thermometer. Again in pressure thermometer, we are it is classified into 3 types. One is vapor pressure thermometer, liquid filled thermometer, and gas filled thermometer. And the third one is a thermocouple thermometer, then resistance thermometer, then radiation pyrometer, and optical pyrometers. So based on the method used adopted in this measuring the temperature, these classifications or the types of thermometers we use generally in practical applications. So whatever temperature we identify, as we discuss the different methods, so one or the other way, some properties of materials are utilized or is used as a function of a temperature. For example, pressure, then volume, length. So whatever change in the temperature occurs, so that will affect the proper change in the properties of those materials. So such a functions means such a properties we considered as a thermometric properties. So the properties which are utilized to measure the temperature of any body, then such a properties are called as thermometric property. So it is a characteristics or a physical property or a reference body which changes with the temperature called thermometric properties. So here are the some set of thermometric properties which are used in some different thermometers. So in alcohol, mercury, in glass thermometer, we use a thermometric property that is length. So change in the temperature, so there will be change in the length. Based on that, we identify some temperature. Then again in electric resistance thermometer, based on the resistance, if there is a change in the temperature, there will be change in the resistance. So again in a thermocouple, we use electromotive force, that is EMF. Then in constant volume gas, the pressure is used. In constant pressure gas, volume is used. Then again in a radiation pyrometer, the intensity of radiation. So that these are the parameters with respect to the thermometers. So based on these properties, the temperatures we can identify by using these thermometers. So let us know what is this temperature scale. So in a thermometer, the temperature is defined as a function of resistance, EMF, pressure, volume, and radiation intensity. So these are nothing but the properties of a material or the thermometric properties. Based on the type of a thermometer used, in establishing means we based on the thermometric property. So in establishing a temperature scale, we need a relationship between temperature and these properties, that is thermometric property. So we must have some relation, so that indicates that should include these temperature as well as thermometric properties. So here are some equations so that are used to measure considered in the temperature scale to measure temperature. So let us discuss the measurement of a temperature. So these temperature measurements are carried by using two standard methods. One is two standard fixed points, that is the method which is adopted before 1954, and after 1954 another method was implemented that is used as a single standard fixed point method. So based on these two methods we measure the temperatures. So one is before 1954, and that is a two standard fixed point method was used, and after 1954 a single fixed point method is utilized to measure the temperature. So let us discuss in details about these methods. The two standard fixed point methods, to establish a temperature scale on easily reproducible state of an arbitrary chosen standard system is considered, so which is called fixed point, and these fixed points are nothing but ice point and the steam points. So these are the two fixed points, that is ice point and steam point. So what is this ice point? So it is the temperature at which pure ice melts at standard pressure. So ice point is a temperature, and this is the lowest point. This is the lowest point in these among these 2 points, lowest temperature point, and it is a temperature at which pure ice melts at standard pressure. So this is a ice point definition. Now the steam point can be, it is a higher temperature point. So it can be defined as the temperature at which the pure water boils at standard pressure. So that is a steam point. It is a temperature at which pure water boils at a standard pressure. So that is a definition for steam point. Now in this method, so that is in a two fixed point methods, first the thermometer is placed in contact with a system whose temperature theta x to be measured, that is unknown body temperature. So in that first we need to place the thermometer, then again we need to place this thermometer with the arbitrarily chosen standard system, that is ice point, where the temperature is theta x1. Then again the variation of temperature can be assumed, means whatever the variation of temperature is there, so that will be assumed as a linear function of x, which is a thermometric property. So x is a thermometric property. Now, so for the first system means when the temperature is placed initially at unknown temperature, then again that the same thermometer is placed in some standard fixed point, that is ice point temperature. So then we have equation theta x1 divided by theta x. So then I can get x1 divided by x. So x is the thermometric properties, and this is a property chain of at standard fixed point, that is at ice point. Then the thermometer at temperature theta x is placed in contact with another chosen standard system, that is at a steam point, where the temperature is theta x2. Then again I will have an equation, that is theta x2 divided by x will be equals to x2 divided by x, where x2 is a property at steam point and x is a property at unknown temperature. Now by dividing the above equation we get theta x1 divided by theta x2 divided by theta x. So above these two, if I divide the equations, then I have this simplified equation, then x1 minus x2 divided by x. Then rearranging these equations, then again if I rearrange this equation, I need to measure this unknown temperature. So then the theta x will be equals to theta x1 minus theta x2 divided by x1 minus x2 into x. So this is an equation used to identify the unknown temperature before 1954, that is by using two standard fixed point. Now let us discuss about the single standard fixed point temperature method. And this method is adopted after 1954. Kelvin pointed out the single fixed point triple, that is a triple point of in a water where ice, liquid water and liquid vapor coexist in a equilibrium, and the temperature at which this condition is observed is 273.16. It is a assigned value, that is 273.16, at which these all three conditions are observed. Now if theta t is a triple point of in a water, that is theta t is a triple point of in a water, then xt is a thermometric property when the body is placed in contact with a water at triple point. That is very important. This is a property at triple point. Then again we have an equation, then assuming that is a direct equation, that is theta t will be equals to a into xt. Xt is the property at a temperature, triple point temperature, and a is a arbitrary constant. Now this constant can be identified by theta t divided by xt. So this theta t is a standard value, that is 273.16. Now we have an equation, that is theta will be equals to a into theta x. So that is a is an unknown temperature, and again this a is a constant, so which we have already identified, and x is a thermometric property. Then substituting this theta in this a in this theta equation, we have theta is equals to 273.16 divided by xt into x. So this is a equation to identify the unknown temperature of a body using a single standard point, that is a triple point. So that is a single point, that is triple point of a water. So by using that one we identify the temperature. So these are the two methods. So first method in which we use a two standard fixed point, that is ice point and steep point, and in a second method we use a one single triple point, that is 273.16 temperature, that is theta will be equals to 273.16 divided by xt into x. Now let us go know what are the different standard points which is internationally accepted. Okay, so these are the some standard points of some different materials, so which in Celsius and as well as in Kelvin I have given. Oxygen point, that is normal boiling point of an oxygen, it is minus 182.97, then again it is in kelvins it will be 1990.19. Similarly some of the melting point of an ice is given, normal boiling point of a water, then boiling point of sulfur is given here, then melting point of silver as well as melting point of a gold in a Celsius as well as in a Kelvin scale it is mentioned. Now the temperature of minus 273 Celsius, so minus 273 Celsius in Celsius scale, and 0 Kelvin in Kelvin scale, and minus 460 degree Fahrenheit in Fahrenheit scale, and 0 Rankine in Rankine cycle is considered as absolute zero temperature. Means minus 273 degrees Celsius in Celsius scale, then 0 Kelvin in Kelvin scale, minus 460 Fahrenheit in Fahrenheit scale, and 0 Rankine in case of Rankine scale. These values are considered as absolute zero temperature, and the temperature measured from these values are called absolute temperature. Means the temperatures measured after these points are called absolute temperature. Now let us see the comparison of a temperature scale. So this is very important topic that we consider while solving the numericals. So let us let the temperature T be the linear function of a thermometric property, that is, and L is a length of a mercury column considered in a Celsius scale. So this is a Celsius scale we are using, and this is a T is a temperature and L is a thermometric property. As it is given, it is a linear function of a thermometric property, then T will be equals to A dot L plus B. So this is a linear function. This is a linear function, and where A, B are the constants. Now let us apply to this scale steam point as well as ice point. What is a steam point? It is nothing but 100 degrees Celsius where water boils, and what is a ice point? It is a 0 degree Celsius where water melts. So let us put these temperature value in this equation, and I will take Ls is a property at steam point and Li is a property at ice point. So after substituting these value, and if I simplify these one, I will get the constants A and B. After simplifying this equation, I will get a constants A will be equals to 100 divided by Ls minus Li, whereas B will be equals to minus 100 divided by Ls minus Li. So these are the two equations or the two constants we identified. Then again by substituting these constants in our equation 1, so we get the equation T will be equals to, in Celsius scale, L minus Li divided by Ls minus Li into 100. So this is a standard equation that is considered in the Celsius scale. Okay. And similarly, we have Fahrenheit, Rankine and Kelvin scale. So these are the equation are used to identify the unknown temperature in different scales. So this is a equation used to identify the unknown temperature in Fahrenheit scale by using two fixed point, that is steam point as well as ice point. And this is a equation used for a Rankine cycle, unknown temperature in a Rankine scale. And this is a equation used to identify the temperature in Kelvin scale. So let us know the relationship between the different temperature scale. So I have considered temperature one side, I have considered degree Celsius, and I have correlated this degree Celsius relationship with the Fahrenheit scale. This is the equation. So if I want to convert that Fahrenheit into degree Celsius, this will be the equation, that is 5 divided by 19 into TF minus 32. Similarly, from if I want to convert this Rankine scale into some Celsius, if I want to identify, then again this is the equation used. And again temperature, so from Kelvin to temperature, that is 5 by 19 into TK minus 273.15. So these are the relation. So these are the relationship that we consider while solving the numericals. So with this we'll wind up the first module theory discussions. So still, if you're not able to understand any concepts, so you just comment it in a comment box and I will try to clarify your doubts.
Click on subscribe button and press the bell icon to get updates from All Academy.